record. So, yeah, hello everybody. Or like the few of you for the first TiXL for Beginners meetup. So originally I thought I would basically do like a full webinar walking you through the user interface and whatnot. But since we are a smaller route, we can also go just for like answering questions and giving you an introduction or background of something you might want to know. Sven, who's like also joining, already mentioned that it would be great to have a small introduction about the types and the backgrounds and some of the terminology. And yeah, if there are any more questions, then let me know. Of course, we can diverge into other topics. So originally, I planned to actually walk you through all the steps of the installation and setup and whatnot. I don't know if you still want me to do this or if you just want to jump right in and like use this installation. I think I deleted it on my hard drive already. And show the installation process. Yeah. So of course give it. So let's quickly install it again. So you see how this will look. And if you keep wondering, so maybe and here we start with the TiXL app, the website, because this will help you a little bit. So sometimes I update this, but not frequently. And the reason why I'm going here is because we have a bunch of links here. Yes, we have YouTube where we post stuff once in a while, and then this is the GitHub Octocat, I think. Then we have, of course, a Discord channel, which you're already on, and then we have Instagram, which I'm signing on once in a while to repost stuff or turn on stuff. But the important thing here will be GitHub, because GitHub has all the resources and all the documentation. And on GitHub, I know it looks intimidating with all the source code and whatnot, but you can ignore most of this. But you should maybe have a look at the wiki, because the wiki is actually, you could say, our documentation. And it's not documentation for developers. There is some development stuff going on down there, but most of the stuff is actually written for people who want to get started with TiXL. And it also has some installation guide and so on. So this is the wiki. And the other thing that is important is these releases pages. And you can see we have quite a lot of releases here. And every time there's a new major release, there are actually release notes. And I will normally try to make a video that summarizes what's going on in this. But yeah, then we have these alpha releases or pre-releases, and I think most of the time it's probably okay to use one of these. So it's the same, the still have this installer and whatnot, but it's just a little bit more features that are up to date. And I just saw that here there is like some kind of weird. I think this one is wrong. Just remove this. So to install it, I could just click here and download it, but I already downloaded it here, and let's just install it. So we can click here, and this will take a while until my Microsoft, I don't know, is this Bitdefender or like this antivirus software, it's now checking this huge executable there that is valid. And eventually it will pop up and ask me where do I want to install it. At least I hope so. Maybe I'm mistaken. Okay, maybe I didn't click it. Okay, let's try this again. Oh, whoa. What's going on? This is taking a long time. More than expected. There it goes. So you probably don't really see this pen window because it popped up as a user account control. And it asked me, do you want to install it? It's from an unknown publisher, and yes, we want to install it. And then then it asked me twice because I clicked it a bunch of times. So and then you can just, I think program files is just fine. You can install it. We can watch it doing its stuff. Once it's installed, so we can't write to program files because this is a locked directory. So for applications only, that means all your settings will go somewhere else, and all your program, like all your projects, will also go somewhere else. So the settings go to this. So maybe we put this up there so we have something you can watch. So if you have your user account, then in there is something called AppData. And in here there's this is Windows, how it manages user settings. Or picture is my name, my username. And then you can go into roaming. I don't know why it's called this way, but these are all different applications installed on my computer. And we see like Signal and Slack and SpeedCrunch and all different things. But somewhere here there's TiXL, and this is basically all these settings we have for TiXL. So we can, I already have .NET installed, so I don't have to do this again. And anyways, so here we have our settings and themes and layouts and whatnot. We also have the backgrounds here, or the backups, which are pretty sizable if you have movies in there. So, it's a pop-up here, I think. It's thinking. Installation takes a while. So anyways, this is the settings, the settings for the roaming and then TiXL. The other folder that you will be interested in is documents, TiXL, and this is where your user project go. And we still have to figure out, so das ist, if we launch it, if we want to launch, we'll launch it. Sadly, with Windows 11, by default, this documents folder is controlled by OneDrive, Microsoft OneDrive, for most users, because Microsoft is talking people into, I don't know, exposing their data, maybe to train AI. I don't know why they're doing this, but they are very, very eager to push people into like sharing their data with Microsoft. And sadly, if this is the case, then OneDrive will fight with TiXL over the control of this folder, which sometimes can give you problems. So yes, let's allow TiXL to send crash reports here. And so if there are any problems, you can start TiXL. You can change this folder in settings, projects, and this is basically, you can use another folder there. For instance, use like C:/TiXL or something like this. Only if it's a problem. But if it's a problem, we will notice because you can't really do stuff. And then let's quickly start a new intro for the in. So I click this plus button there to create something that we call a project. And if we do this, then we have our default playground there. Takes a while, then let me show up there. Intro for beginners, and then we can jump in there. Yeah, so Sven, you mentioned you are curious in like, not really sure, like the different types of operators, or what are you curious about?
So it's more about how to think, because I understand that, let's say we use a radial point and then we draw the point, that I can understand it, but it's more about, do we need to have like a concept before doing anything? Or of course we can improvise, but maybe there is a workflow which is efficient.
I think that's a great question. So I personally would advise to use both. So meaning, so just let your inspiration go and experiment all the time, and then don't really care if it's getting slow, because it's easy to refactor things. Refactor meaning to rebuild something without really changing like the output, but just optimizing it. So that said, TiXL is it's a real-time application, and if you don't, or if you completely ignore that fact, you eventually will run into problems, and then it will be too slow. So, and I think I want to point out two sites here we have on this wiki page. Increase the font size here, increase the window size. So one is real-time rendering for artists, and I think it's a little bit technical, but on the other hand, it's stuff you might probably eventually want to know, because you will encounter them, and then you might be like, "Oh, what's going on? Why is this like so complicated?" And some stuff, sadly, tends to be scary in the beginning, so it takes a while to get into this. So this page is still a work in progress. So if there are more questions, then let me know. I will complete this. But I can show you like a little bit of what to pay attention to, if this is okay.
Okay, thank you.
So so you can so I have this little up here. I press tab. It's called Sketch. And if I press this, I can it's a little bit like a sketch pad. I can press 2, and then I can draw something here, which is sometimes useful for me to just explain stuff. And so you can imagine TiXL as being something like this. So there is, let's say, there is a frame. Like, once every like 60 times a second, we evaluate this frame. And then there are two layers. The first thing is that we have things, I would call it, on the CPU, and then we have things on the GPU. This is what makes TiXL fast, but also which sometimes is a little bit annoying, because you need to keep this in mind, and some things are a little bit more difficult to do on the GPU. So on the CPU, we do all like these. Where is an operator? What's the size of an operator? What's the name of these operators? Like editing, properties, loading files, whatnot. Everything is done on the CPU. And then based on that, we generate resources and upload them to the GPU. You can imagine this could be, for instance, it could be points. It could be textures, like text. It could be, I think, honestly, this is almost like obviously it could be like 3D data, right? But all of these are buffers, and so they are created on GPU inside your GPU memory, and then they are being processed there. And so every frame, we constantly look at things that we need to have on the GPU. And once they are there on the GPU, we use them to process things. And there are only two ways to process them. The one thing is we can basically compute. So we draw, on the CPU, we draw a compute with like a bunch of resources saying, move these points from there to there. Or we can use these points on a new position to draw billboards. And once we did all of this, we go to the next frame. So this is in the next frame and so on. So if we have operators, so let's bring up this the symbol library here. So these operators, let's say we have like this. Let's say we have this raster thing here. So these operators, they have a color, and this color is defined by the primary output of this operator. And in this case, if I hover over here, it will tell me this output is a texture 2D. And we actually see the texture here. It's like it's a texture format. In this case, it's 16-bit color depth, and it's 878 by 553 pixels. And it's something on the GPU. So like it's not on a main memory, but it's lying on your graphics cards, you could say. And every time we modify this thing, we generate a new resource on the graphics card or update it. Then there are operators. There are similar operators. Let's say here in point generate. Let's say we have GridPoints. Then these are brownish because these are buffers. And don't really have to understand what buffer with you means, but you should keep in mind that it's also something on the GPU. If we look at this buffer, then we only see its size because by itself, it's just a pointer into this. And like it's like we have a buffer here on the GPU, but the only thing we know about it is, hey, somewhere there's a buffer of a certain size, but we don't know its content, and we can't simply read it back, or so we can't show it. But we can use this buffer to draw things. So let's draw points. And then basically, this is like the third important color, this green here, which is always, like you can imagine it to be, so this thing, every time there's something that is being drawn or updated or a command simple graphics card, and it's going. This is, you have questions so far?
It's clear.
Okay. So now, I think the most of the time, I would say, you can, so I'm trying to figure out like how to structure this. So regarding the creative process. So I think there are no strict rules of what to do and what not to do, sadly. Sadly, it's not like driving your car in traffic or so, where there are like a bunch of rules and then everything is clear. But it's like things are fluent, and the performance bottlenecks are like sometimes different to spot. But I personally would say just get started, and you will notice when it's getting slow. And for instance, we can try like a bunch of things. So the typical bottlenecks you might encounter is so maybe we go back to our sketch here and to go there and then jump a little bit ahead. So like the three things you will see is like draw. This is like the worst. This should be an A. Drawing too much. So this would be too many polys. Then the next thing, I think it's sometimes called fill rate and sometimes called overdraw. So you draw not that much, but you draw the same pixels over and over again. And you will see this. And the next thing is basically like, this is too many, this is too much, this is like, on top of each other. And then there will be things like memory. And most of the time things should be fine, but we can provoke all these three to get to see what's going on, to feel a little bit what might be a problem. So let's start with these guys here. So we have 100 points. And if you go up here, we see, if we hover over here, this is the performance graph. And we can see that right now we are running with these 60 milliseconds. We have a little bit of like GC stands for garbage collection, but you can ignore like all these things. The only thing up there that's important is the frame rate. And what might be interesting later is the smaller numbers down there. So right now we're executing one compute shader. We have 200 triangles, which roughly we have 100 points. And each point is 2 triangles. We can only draw triangles. This is something the graphics card can only handle triangles. So it's 200 times 2 to draw a quad. And then we have two draw calls. And I don't know why there's two draw calls, but yeah, I think this is just fine. And we are not rendering anything. So now, if I'm increasing the number here of my points, I can take the infinity slider here, I can go up until like the number here increases drastically, and then I can increase this like significantly. So now we have basically, we have 2 million points now. And so we see that right now, like the frame rate is like, this is like a lot of points. So it's no longer 60 frames per second. Okay, I'm running on my notebook here, and we are also capturing things. We're capturing. And then we are also sharing it with Discord, which makes it double slow. If you draw too much, with too many items, the polycount is too high. So you might want to find the right amount of things you want to draw. So let's bring this down, let's say half it, and then it's almost fine. So like if we see something like this is almost on the verge of being, yeah, I could make it. And if it's like a little bit like this, like unsteadily, then if you have a notebook, then there's something called thermal throttling, which means if your notebook gets too warm, the GPU will rather do less work than burn itself up. So, and then basically this leads to this unrhythmic jittering there. So on a desktop graphic card, you don't have this effect. So anyways, if I click here once to reset this, of course, we are back to the 16 frames per second. And then we can look at the second thing, like the fill rate thing. So now we have, let's make this 500 points. So obviously this should be fast. But if we increase the size of these points, then eventually there will be, it will get slow again, because all these points are drawn on top of each other. And so like each of these pixels has to be drawn over and over again. So if we increase this further, is it still fast? Okay, this increased maybe 1,000 points. It's still fast. Maybe maybe disable viewpoint or something like this. It's still fast, but we see a little bit of jittering, so maybe 2,000 or something. Yeah, and now we see jittering again. So it's like much less points, but it's much more. It's like we draw much more pixels with these points, and this is also driving the graphics cards. The graphics card doesn't like this. So, and as soon as we bring down the radius again, then the performance will be back again to normal. So this is clear so far.
So not trying too much. We have to be aware of the power of our computers.
Yeah. I mean, I want to emphasize: don't be scared or intimidated. Just keep this thing up there in mind, and then you want to look like something. If it's getting really slow, then most of the time the bottleneck is like 1 or 2 operators or settings. And then you can basically adjust these or find different ways to work around these. So I would, like most of the time you don't need millions and millions of points. So, or you don't need like thousands of layers on top of each other. Also, yeah. So I think just keeping it in mind already helps. We can like now for like the third point, this would be texture memory or memory in terms. So if you look at these points, so these are so we have 2,000 points, and each point is 64 bytes on our GPU, and a byte is 8 bits. I don't know if this is useful knowledge, but you can think about this as being 128 kilobyte. So it's really like, what's like 1/8 of a megabyte. And my graphics card has like 8 gigabytes. So you can have like 8,000 times like this. So like, like it's like the graphics card is actually, there's plenty of memory for like these guys. However, if you use these guys, then TiXL is something. It's a little bit different than other real-time tools, because we okay, let's move this guy and move it on there, plop it in there, and then use a camera and then a render target. So the reason I did this is I draw these points, and I set a camera so I can still move this around. And then I use the current resolution to draw these points into a texture. So and if I'm with the texture and I drag here over the second, it's the action over. So if I used my left mouse button to drag this, nothing really happens because this is now an image. And this image has 800, like it has a current resolution. So if I drag this window and change its size, we see how this will change its size there. And now if I can change the resolution here, so I can use the fill, like the resolution mode here, and for instance change this to 8K. So now this is 7,680 by 4,320. So like this is a very, very, very high resolution texture, and I can move in there quite a lot. Yeah. And now, and if you do something like color grade, and let's say I in this guy and I adjust the colors here, then you might think, I take this buffer and then I apply something to this buffer, but this is not what TiXL does. TiXL takes this buffer and creates a new buffer with the same size and then applies to this new buffer this color grading. The reason we do this is that sometimes you want to do things like, let's say if we take this guy and have like a bloom effect here, so like, like some kind of glow, then it's useful to have this buffer still there because we can do things like have, for example, like a displace and use the original with this blue thing and use them to apply effects on each other. And you couldn't do this if this buffer would be thrown away. And now we can always see, like, this is no longer, it's also no longer fluid because blue is a pretty expensive effect because it does like multiple cascades to have this soft glow effect here. And if we do this multiple cascades, multiple effect passes, you could say, on this 8K texture. And if we look at our window here, we see that right now we are drawing 99 million pixels every frame, which is like a little bit, it's just a lot. And so if we change this to 4K, then things go back to normal. And if we go to full HD, then of course we are beyond normal. You can also click this thing here to toggle V-blank or vertical synchronization. And so this will then, if disabled, it will no longer wait for the next frame and will draw as fast as possible. And then it's a little bit easier to see the current speed. So right now we are drawing everything in 3 milliseconds. And if you change the C to 4K, then we're drawing it in 9 milliseconds. So you can, and now it's stalling because the graphics card got too hot. So this is a typical stalling thing. And suddenly it gets like slow after a while. Yeah. I don't know. It's just that I think it's maybe not really like the topic for beginners, but yeah, it's still important background knowledge, I guess.
Yeah. Well, everything is useful always.
A lot more people joined. Hello, everybody. Welcome. So now, of course, my structure is already out of the window. So I think I want to use maybe unstructured. So I want to do these kinds of meetups for beginners every month now, from now on. So, and I plan to do this every first Sunday of a month. So the next one will be like the first Sunday. And I think most of the time, maybe next time there might be more people because I will announce it on Instagram and whatnot. So it might not be super relevant to you because you already know everything. But I would basically go through the user interface and quickly showcase how to build stuff. And I think it might be a good idea if we use the rest of this beginners meetup for me to build a little bit. And you guys and girls try to follow along. What do you think? I know it's like hard to speak.
Sounds amazing. Sounds so good.
Yes. But I was also thinking for the future, maybe if it's a good idea to have like a basic concept and all the beginners try to replicate it on their own. So we try to
Yep.
redraw something, you see.
Yeah, I think this is, I think this matches a little bit what I have in mind for today.
Okay.
So I think ideally you all would have TiXL already installed, and the Blender donut. No, not the Blender donut. Although it would be interesting. Actually, kind of now that I think about it, I think we can even do this a little bit, but maybe not. Yeah, anyways. So if the Blender donut, okay, the Blender donut is so oh, I get a warning here that my frame rate might not be on par with the thing I actually want to stream, but yeah, let's see. So I go ahead, but you should interrupt me if I'm too fast, if you basically can't catch up, or if there was a mistake or something, and then it would be great if you could share your screen. Yeah, and then we see how far we get. And I think I have a time limit here. So maybe I have another hour or so. Let's see how far we get. Yeah, okay. So let's get this out of the way. Just remove it. And basically we go to the project tab, and then we click the plus, and then we create a project. And then I'm here, and I will wait a little bit until you tell me you are there. How do I figure this out in Discord? I think I will just ask, can you follow? And if there is no until like within like some while, then I will just continue. So do you have the new, let me know if you managed to create this new project there. Or no, the other way. Let me know if you don't manage to create this new project.
It's already a failure because I can't install TiXL yet, as you know. But I will. The thing is, we need to have Sequoia to macOS to make it work.
Yeah, okay. I would keep this out for tonight, I think, sadly. But others, yeah. I think like this whole question of a Mac version, this would be so great, a native one without simulation, but it will take a while. Getting there, but yeah, slowly but steadily. Okay, so a bunch of people in the chat said, let's try to build a donut, like the Blender donut. And it's a surprisingly interesting topic because it involves all kinds of different things. And so let's just try that. So to start with, we can say, okay, if we long press on the background, long press, and search for donut, we get a bunch of bunch of results, which is already interesting because we find tools, because we added synonyms to our operator description, but we don't call it donut, we call it a torus, which is the fancy mathematical term to name a donut. I don't know why, but this is how computer graphic people call a donut. Interesting enough, it also finds MIDI control output, and if you are wondering why does it do this, it does do this because the DONUT letters are in this word. DONTUT is somewhere there. And so if you are wondering why, like this is like this is a bug. This is not a bug. This is great because you can most of the time type something and it will find something. It will prefer things with uppercases. So if you type TM, it will find the torus mesh pretty up there. It will also find transform mesh because it's even more frequent in the torus mesh. But yeah, you will tone mapping TM and so on. And yeah, and if you just find this will also work, but like this would also work. Sometimes you might want to find the torus even if you have like a small typo in there. So anyways, we can create these two toroi. I don't know what is the correct term is. And try to figure out like, okay, what's going on here? Why do we have two of them? So the first one, if we hover over this output here, it will tell us the output, and the output here is a mesh buffer. I can just click there, and it will suggest things that go from the torus mesh to this output. So what would be good connections here? And it will do statistical analysis and some smart things to figure out the sort order here, and it will suggest most of the time people draw a mesh, but sometimes they also transform a mesh and then there are different ways to draw things and so on. So let's just draw this mesh, and there's a donut. And maybe I will enable the VSync here. So donut. So now what's this guy here? If we hover over the output, it will tell us the result is a shader graph node. And if we click on this, it will tell us what to draw a mesh. This is actually like a very unfortunate suggestion, but it's valid. But we don't go there. So the secret here is this is actually a field, and we can rematch this field with rematch field. It's a new operator. They look pretty much the same, which is the way it should be. So if I hit P, we see it looks a little bit different. The reason for this is that the rematching thing has like this AO distance, and if I click this up, we see that there's a little bit more shadow coming there in this thing. For the Blender donut, I would go with this guy. It's a little bit of cheating, but on the other hand, you asked for it. So we stick with the rematching thing for now. So most of the time what we want then is, and of course I will ask, is like, let me know if you have any questions. So just, yeah. And I'm not checking, I only have one display here, so I'm not checking the chat constantly, so you have to use your voice. Okay, so no vetoes, so I will just continue. So most of the time, if you do things, you will have this setup here. The output window will be in the mode fill, and it will fill the size of this output window. And if I change this size here, it will automatically adjust the sides left and right. So it will not touch the upper and lower bounders. So this will be the vertical extent will match. But on the left and right, we will add more space to conform to the aspect ratio we have currently set. So in a real-world project, you want to control the camera, because right now this thing here is the camera of this viewer, the output viewer. And so if I rotate the camera, there are no parameters that tell you where this camera is. So we need to create a camera operator here. So we can click the plus. And most of the time, if you click the plus, the suggestions you get here, like the first 10 are probably ops you might want to know about. You can hover over here. It will tell you a little bit of what these things do. Sometimes they're a little bit more complicated, so you can ignore a time clip for now. But here, for instance, we see we have our camera. And we have to look at this camera. So let's press this pin output button here. And now if we drag our view here, we see how the position is being updated. And we actually now have parameters that control our camera position. And I would save this project now. Go to here to save changes. Then these parameters would have been saved. Whereas if I go here, okay, this, and select like a perspective, this position would not have been changed because this is just a temporary view of this viewer here. So then eventually we want to render these stuff into an image. This is just the way things work in TiXL, is that the final output is normally an image. And then we see that, okay, we get like some resolution here. We can actually click this button, screenshot button here. It tells us, hey, I saved a screenshot. We can go to our documents, TiXL folder, to our intro for beginners. And here it just created the screenshots folder. And we can go in here, and then if we double click here, then we should see our tools with this resolution 804 by 504, which it says here. Most of the time you want to control this resolution properly. So I don't know, you want to do something for Instagram or whatnot, or like for YouTube, then you can pick one of these resolutions here. So for instance, 1080p. And now it will scale down this picture to fit into this frame. It will conform, it will, like TiXL will always try to conform to the aspect ratio. Circle should be a round circle, not ellipse. And so it rather pushes pixels to the sides. And now what you see, like this 1-to-1 pixel, it will, like this is the sign that, this is no longer pixel perfect, but you could click here. And then now it's pixel perfect, and you can zoom in and see how this pixels look like. But now see, but it's no longer fitting into the output, so you can basically, you know, have the choice. Do you want to squeeze it down or fit it? So let's stick with fit. And yeah, so I guess we can quickly talk about this right now. The information looks like it's flowing from the left to the right. If you long press something, you select only one operator. And if you long press something and drag it, you can disconnect it. And then you might be confused about this new TiXL graph system here. So if we drag this thing here, it looks all fine. But if I drag it here, eventually it will snap towards a vertical connection line. And you're like, why are there even two dots here? For this is that sometimes it's better to have things horizontally, sometimes better to have things vertically. And it's a matter of taste. So I personally like to have render pipelines, so that go from one type towards the final type in a vertical fashion. So we can basically take this guy, long press, drag it up there, and then take this guy, long press, take it up there, and then now these are stacked into one batch. If I press any of these without cursor selecting one, then I will drag the whole stack because it's snapped. If I long press this, I can drag it away, and if I can shake it, then I disconnect it. So, now we can start to add stuff on either side. So we can add stuff towards the SDF. We can add stuff towards the draw process, and we can add stuff towards the image we are adding. And let's do each of these things. So let's start by coloring our donut here. So to do this, we can set either a material towards the field, an SDF field. And if you are unsure what the SDF field, what it actually means, I can recommend to you YouTube. And then we have TiXL shader guard or something like this. And you want to watch this video. So this basically goes in depth about everything related to this whole shader graph system. So let's quickly add something there just to see how this works. So we can maybe add a noise display shader. So I noticed that if we click on these guys, like on these arrows connecting these nodes, then we get a small plus. And if I click there, I can actually insert a node that matches. And once again, TiXL will sort these suggestions by relevancy. And we can maybe use this noise displays SDF. Click here. And then we see like, oh, okay, like what's happened to our, this is no longer a donut. But if we bring down the noise here, then we see, okay, maybe, like donut should be maybe not mathematically precise, but have like a little bit of structure in there. If you want to adjust the perspective here, you might be wondering, if I click here, nothing happens because this currently is pinned to this image, indicated by this white border there. So, and it's obviously fitted in there. So if we would want to change the camera, you can click here and adjust the camera parameter. Or if you are, this is not selected, you can use the camera select or control and use this camera, and you will see the camera blinking there in the graph. If I'm hovering here, and then we can pin to this guy. It will say, no, it's locked to an operator, and now we can also pin it. And this is sometimes useful because you want to work with images, but you still want to control the camera. So, any questions? Okay, no, we do. Then I will continue. The next thing, let's add some color to this guy. And we add color by setting materials. And this is actually a good point here, because if we if we click here, let's do this again. If we click once, like if it's an important operator, it should be suggested, and it's here. Like, it's the number 4 of our suggestions is the SetMaterial, because it's very frequent. And it works for meshes and SDF alike. It doesn't really matter. And we can already see how this now got a little bit shiny. If I bypass it, we see that it's with or without this material. And if we further reduce the glossiness, then eventually it becomes almost, I wouldn't want to eat that. But this actually looks more like frosted something. Okay. And then maybe we just, I think the blender, what was it? The blender was like a little bit like this, I guess. Oh no, wait a second. It was more like this and brighter, I think. So now what's interesting here is if we add another material, so let's call this material pink. We can rename something by either clicking into this field, untitled instance, and type something like hello you, and you can pick whatever you want. We see that we got these double quotation marks there that tell us, hey, this operator got renamed. And then you might be wondering, oh, like, but, this is a new name. How do I figure out what kind of operator it is? Then you can just click this operator and look in the top left corner, and it will tell you this is a SetMaterial. And then you can rename this and see the SetMaterial name there again. Alternatively, you can just select something with a single click and press return and then type something. And let's call this pink. We can create let's call it pink material. If we select this and press Ctrl D, we can also select something and look at the right mouse button with the context menu, and we see somewhere here there should be duplicate, Ctrl D. Then we get a copy of this. And the Ctrl D pastes it wherever your mouse pointer is. So we can have something and press like Ctrl D and place everything with materials. If it's not connected to our graph, it's being ignored by TiXL. So this will have no performance implications whatsoever. You will need to connect it to make it matter, which is a good thing because, just you want to make a safety copy, so you can just duplicate it and paste it onto the site. So at a time. And now if we take this guy and change its color, let's say we make this a blue donut, and maybe also press return donut, blue material. And then, of course, it's not being used because it's not in the stack. But we can take it and drag it into the stack. And you actually see, this might be interesting. If I start dragging here, you might see that there are two cursors blinking. Like the vertical line blinking and a horizontal line blinking on top. And the reason we have this is we see that we also have these line blinking here, and these are the insertion points. And so if we have a group here, we get this group. So if I'm once again dragging this, then we see now that there's one blinking there and a bunch of lines blinking here. It's not blinking here because you can't insert this here, but you can insert it there. If you place the blinking line on top of the blinking line, then we see how this they will make some room. We can also insert it here, here, or here, but not there. So and then the interesting thing is, I'm keep holding the mouse button here. So if I'm putting it above the pink material, it's being applied. If it's below the pink material, it's not applied. And then the reason for this is that the flow of data is actually not like this, but internally everything starts with the output, which is this thing here, and the output is pinned to this guy. And then this guy asked, hey, give me something. And then this guy, the camera, asks, yeah, I want to give you something, but before this, I want to set up a perspective. And then, then it asks its input, hey, give me something. And this guy, I give you something, but I first set the material. And then this guy comes and says, like, I give you something, but I override this material because I'm the last one. And this guy then asks, like, okay, I want to have a field, and then this eventually will be rendered, and this will be then the output. So, and the same goes for cameras. So we have the camera A here, camera 1, or camera A, and we duplicate this. Once again, if we drag this here, and we rename it to camera B, and now change this to camera B. If I rotate this, nothing happens here because it's only being applied if it's like the final camera in the stack. You might be wondering if this is a good idea, but there are many situations where you want that. when you want all your objects to be a certain material, but then one of these objects to be another material. Any questions so far? Am I still there? Am I still on the call?
There you are.
Okay. So, I hope the speed is okay. Or is it too slow or too fast? So too in depth? I always like unknowing. But yeah, if nobody complains, maybe it's like, it's a good time. Vacation camp with the kids or something. Nobody quits, everything is all right. Okay, so then let's, so we added a bunch of things here. Maybe we add, maybe we make this thing into, so let's first get rid of our SetMaterial and maybe, or a second camera, and like, let's get rid of our SetMaterial here to keep it simple. We are locked to camera B, which is good. Let's make this into a scene, because, you might be wondering, okay, like how do we actually have more than one donut? And you do this by having, groups. And there are two types of groups. Most of the time, group is okay, but execute, can remember, like this guy here is a group for developers. Group also has a position, and you can move things around, and it has like color, and but sometimes you will see execute, and you wonder why it's execute. It's the same thing without the position and a little faster. So, now we see that we have on the left side, we have this guy here, and this is actually something that's a little bit confusing, and I should really clear this up. So if I select all of these and drag these out, then we see that this can go in there. So the first input can go be on top, but actually it's a little bit easier to see if it's on the left side. And then whenever you have this graphical representation, this means that there are there can be as many inputs as you want. This is called a multi-input. And so we could take this guy and drag it in there, and you will see every time we drag something out, you will see these blinking lines. And we have there, and there. So these are all like valid inputs here. But important here, next to our multi-input, we see these insertion points. And this is where I can have another connection. And this is completely valid. So this means we render our object twice. And if you wonder, like, why would anybody do this? Well, maybe you have like a transparent object and you want to make it like more transparent or something like this. So, or like increase the opacity. So, so let's increase this again. I just noticed that my frame rate was going down because we are waymarching, and doing this means that we remarch this whole thing twice in full HD, which is a little bit slow for my notebook here. So actually, let's go back to Phil here to reduce the frame rate a little bit. So anyways, we can create a new operator. Let's create something like a floor. So we can create a cloud mesh here. And then we click here. We take the first one that's being suggested, which is draw mesh. We take the output of the draw mesh, and once again we see things blinking, so we can override this into the render target, the camera, or like one of these the slot for a group. And then we see if we take the second one, it will be inserted there. Now it looks a little bit strange because it looks like our toes is filled from one side, which is what's going on. And this is actually very interesting because we learned something that obviously, or like what's even going on. So like, why is this a circle? Okay, it's a circle because it's just a 3 dimensional object. And then we see if we take the second one, it will be inserted there. Now it looks a little bit strange because it looks like our toes is filled from one side, which is what's going on. And this is actually very interesting because we learned something that obviously, or like what's even going on. So like, why is this a circle? Okay, it's a circle because by coincidence fits just the size of the wall of our of our Tori there. And we could adjust the scale here. But the interesting thing is that the Y is not only drawn from one side. And this actually goes back to this whole real-time thing. And so we want to draw as much as required, but as little as necessary. So in this case, most of the time, we only want to draw a surface from one side. And that's why and I wish I would have called this differently, but this is the technical term is culling, which means something like leave something away, filter it out. And right now we cull everything that's on the back side. And if we go to the back side and we switch this to front side, then we see this is now the back side, we only see the back side. And if there's no culling, then we see it on both sides. And believe me, I very much would love to rename this parameter into like both-sidedness or something like this. But yeah, this is one of these things. This would be a breaking change and not so easy. Otherwise, I would have renamed this already. But yeah, now you know culling is the thing you're looking for, both-sided things. We obviously see, okay, this is not a floor. This is, I don't know what this is. Maybe like a portal, donut portal or something, but it's not the floor. The floor needs to be pointed up. And to point this thing up, we actually need to rotate it. And we can rotate this here. And this is a rotation here. This is an angles, rotation X, Y, Z. And maybe we skip the back to here. And maybe we look at this guy here. Oh, sorry. Look at this guy and not go to autos. So you eventually you will need to pay attention to coordinates because this will just make things easier. And conveniently, like most other 3D applications, we use red, green, and blue, so RGB, to map our X, Y, and Z coordinates. And different than Blender, we are having a Y arc. So Z is coming out of the camera, X is going towards the right, and Y is going up. And if you're wondering why is this the case, there is no right or wrong besides Unreal. So Unreal is the only application that actually makes it wrong, but everybody else is like, this is for instance, this is the way Maya does it. But also interesting is that eventually, once in a while, you might be wondering, so what's like the rotation angles, like in which are you rotating counterclockwise or clockwise? So this thing here is called a right-handed coordinate system, because if you take your thumb, this is your thumb, and this is your, I think, pointy finger, and this is your middle finger, then you can also only do this with your right hand and not your left hand. And for instance, like in Unity, like this thing is pointing there, which is left-hand coordinate system. So yeah, I'm going a little bit, maybe too much in detail, but this side might be interesting once in a while. So anyways, rotation X, Y, Z. We take the X coordinate, because we see this red line. We want to rotate here. We draw this infinity up there, and then we rotate it counterclockwise because we are on the right coordinate. Yeah, anyways, let's not go there. So we increase the size here. Now we cut it. Obviously, we want to move this thing down a little bit. Now you have two options. You can translate the mesh, or you can translate where the mesh is being drawn. And this might be interesting and relevant later. So let's cover both. We can go into here and use So when I click here or click here, I most of the time get things that are meaningful suggestions. And here, the first thing is actually transform mesh, precisely what we want to do. So we click transform mesh. We get our transform gizmo here because we enabled it up there. And we can pick the y-axis and the odd down. Okay, let's take this thing and drag it down. The other alternative would be to click here, and then we see there's a transform here, which is doing the same thing. So now, we picked like this, like it needs to be like 1981. So if you have a value that you want to copy it over there, you can actually use right click, copy, and right click here and paste values, and it will look for parameters of the same name and insert them there. It finds this translation in here, and sometimes this is useful. Okay, and then sometimes it's like to rename stuff, so let's return and name this floor. Our floor here. And then I can take this guy again and press P to bring it back. We select our camera, use the mouse wheel to bring it back a little bit, and then we can go in here and increase the size. So far, any questions?
I think it's all good for now.
Okay. So you might be wondering, see, how do I get shadows in there? I don't want to go there. It's a little bit finicky to set up, but we can fake it, which is also sometimes something you might want to. It's a good exercise. So, and faking is the name of the game when it comes to real-time stuff. So let's bring in some light. So the first thing is that you might be wondering, where's the slide that we currently have is coming from? Which is interesting. Obviously there is some light here, so we have some reflections coming up from here, and like this. Obviously there seems to be a light up there. So where is this coming from? And the reason, like for this, is that we have a default lighting, and by default this is on, and you have to switch it off. This is a conscious decision. It might not be the best decision, but this is a decision we once made. That if you start simple, you immediately see stuff, so you don't have to create lights to see something. So you don't start with a back scene. But so let's say we want to have full control of our light. So how do we do this? So we start by creating some lights. We can click here and we insert a point light. So right there we have a light, and we can move it around, and we see a little bit of reflection going there on the floor. We see this guy here. We see that it has a brightness, intensity, and we can click on maybe like form light or something like this. So let's say we only want that light. But then the question is, where's the rest of the light coming from? So why is this side still not black? No, it's away from the other point light there. And the reason for this is that this is what we call direct light, or like from point light. But we also have indirect light, which is sometimes called image-based lighting, EBL, or sometimes people call it HDRI. Not HDR, I think, high definition render imaging or something like this. So this is what's setting the environment there. And the operator for that is SetEnvironment. And if we click this, we see nothing really changed, but we can switch this to different modes. There are a bunch of predefined modes here. We can also switch to black, which basically turns it off, and this is what we what we get, or like our little point light here. And we see that sometimes we get operators that have an input here, and that they warn us, hey, I'm missing an input here, and this requires a texture. This is actually no longer true. So because we now have these presets here, and sometimes let's say if we take this preset and then we would disable our floor plane, so this would already give us some consistent lighting within this environment. And we can say, actually, I don't care for this environment. Please don't render it. And we have a bunch of settings here, how strong this should be visible, or even like how bright it should be. Sometimes this is useful to have. And same with this studio setup here. So if I rotate this around, these little spots there, and if I decrease the background blur, then we actually see how, I don't know, like this from HDR erheben or something, we see a little bit white plot there. Yeah, interesting. So let's click on the parameter names to reset all these guys. And then maybe we switch it to black to start one scratch here. Move our camera, here's our light, go into our floor, disable bypass, maybe take the point light, increase the brightness here a little bit, and maybe create another point light where like the stage lights right there. And then redirect this guy here and maybe put down a little bit to have a little bit of blue lighting or something like this. So there, maybe we can increase the range. Okay. So now you might be wondering, I want to get rid of these light gizmos there. They are on the way, but I want to see the gizmos if I want to transform something. Then you can go into show gizmo parameters and turn them to something like only if selected. And now these point light gizmo only visible. Actually select something. So now let's fake some shadow there. So we can do that by lump on the background. And we can quickly talk about this menu because it's sometimes super useful. So this menu basically force you, let's say 80% of all the operators you will ever need in TiXL, and groups them nicely into different categories. So everything related to numbers, or to images, or to points, or to particles, and so on. And now I actually wanted to create a blob. We can go to image, then away. And then you see here that there is a basic shape called blob. Click there, and then I have a blob here. And I want to draw this thing on the floor, would be our fake shadow. So we can actually take everything we have there, or like we take the mesh. We have the floor, so we looks like we have like this already, and now we can actually think about like how do I restructure our scene. So like the first thing is, okay, maybe our floor is not just this plane right now, but maybe also like something that's on the same plane but the fake shadow. We can click on the thing again to create it inside the groove. And now I take like these two, I duplicate them, and actually I don't want to use this guy here because I don't want to be shading. I want to use only a texture. And for this we use draw mesh on it. I can see art and take the slot, and here we can connect this, but you can also just take this guy and move it closer, bring it towards the texture, and it will snap right in there. And now we have to also connect it to our group. And now we see our texture there. So way too big, so to bring it down, and then we can bring up this thing. And we see a bunch of things, and we can talk about each of these. The one thing is, you might have noticed that sometimes we have this graphical glitch. This is called leaf fighting or Z fighting, and this occurs if two objects are a little bit too close to each other. And there are different ways to mitigate this. And one option, for instance, is to move it slightly up. And if you think that is cheating, well, it's not cheating if it solves the problem. So sometimes it's completely legit. Another way would be to basically play with these disable Z test. Actually, let's just talk about like what's going on here. So, so what does this even mean? So Z, if you remember, if you go back to this guy here, Z is the axis that's coming out of the camera. So it's the direction of the camera, and it's the distance from the camera plane. So you can say it like it's the short form for the depth. And there's another buffer in parallel of this color buffer here. That's called the Z buffer. And a fun fact, the Z buffer was actually invented by Edmund Cutmill, who's the CEO of Pixar. So if you ever want to look for the CEO that actually knows the shit, that Cutmill is your guide. So he invented the Z buffer. And anyway, so this thing tests if I draw a pixel or not by looking at the Z buffer, and if it's too far behind, it's no longer being drawn. If we disable this test, then we draw it whatever, like it doesn't matter where in the depth like the pixel is, it will be drawn. And in this case, it will be drawn on top of our tools here. And okay, like this one, like you can work around this by taking this guy and changing the draw order. But right now the draw order is defined by the number of these inputs in the group. So we can replace it and drag it over there and then change the draw order again. Then the next question would be, okay, like I don't want to, it shouldn't be white, it should be black because obviously it's the shadow. So we can, fastest way is actually not to go in here and do this. Fastest way in TiXL is a shortcut. So you can right click here, so right click and drag this thing down with the right mouse button. And basically this will adjust the opacity. And you can also like use left mouse button. This will adjust the the right mouse button will adjust the luminosity. The left mouse button will adjust the opacity. Alpha. It's super useful to quick adjust. And then one last thing here, you might be wondering, so what's going on here? So like why is our shadow getting squeezed together? So the reason for this is that if we look at our blob here of our operator, we see that we get a nice little preview of our texture. And you might have noticed that this aspect ratio matches this aspect ratio. And if we adjust that, we actually see how these things are updated live. And obviously this is not what we want because our spot mesh has a uniform aspect ratio. So obviously when we could go in here and like say like, I go in here and then I squeeze this thing to match our white aspect ratio there. But actually what we want is we want to set the correct resolution for our texture. Right now, this resolution has 0, 0, which is like, this is not a valid resolution. Well, in TiXL, it is. TiXL just means take the current output resolution. And it's something that is like super useful for all kinds of things. You know, let's say, you would want to have like let's say like a special effect texture like raster. So sometimes this is just what you want. You know, you want precisely this. Let's say, so maybe take this procedural texture, and we want to add it on top of our screen here. So we can click after the camera, insert a group, and then make sure not to use the center thing here, but to insert it after. And now, like this thing is being rendered on top of our screen. And we see that it nicely matches like our current setup here. And we see we have these two lines here and we have 3 lines here. If it's just enough to get another line, see how this line is coming. Yeah. So this is super useful. And once again, the resolution here is 0, 0. So this is the smart resolution. So maybe keep this for later. So just disconnect it. This guy out. Bring this in here. So what we want is fixed resolution. And let's, it's the blurred texture anyways. So like, we can get it as low as we want with like 256 bytes. Pixels. And there we have it. And then of course we can go in here and maybe adjust the size of our parameters and maybe adjust the opacity. So we can adjust the opacity here. We can adjust the opacity here. So I'm always using the left mouse button. We can adjust the opacity here. Okay, this would be the complete floor. You see there are many ways to adjust. Yeah. Any questions? So we are learning, covering a lot. No questions. Excellent. So, so we talked about a lot of these teal colors. So draw commands and parameters we can add towards like how things are being drawn. And I earlier mentioned, hey, we can adjust things towards the things like that are being drawn. So either the SDF or like we already had this transform mesh there. So, and of course we can add things towards our image that is being drawn. And so, yeah, if you click here with the plus, we see a bunch of recommendations that are useful. Obviously, we have like all kinds of crazy, like either like very simple effects. Okay, take a blob. It's an update button here. Like take a blob on that and then just add it. Why would you want to do this? Well, you could say, okay, maybe I bring this down and I bring this down to opacity and then I bring this and this up. And now we have basically a vignette effect. So like completely legit, just basically add a negative blob. So like, no, there's like nothing wrong with this. We can also click here and we add like any of other effects. For instance, like we could have a bloom And if we bring this up, so we see like some glow. Frequently, these parameters have a lot of these operators have a lot of parameters. We try to keep the number of parameters low, but sometimes we basically add parameters if you think that this would be super useful. And so okay, let's put like here an interesting thing is so obviously okay, the intensity is like this is the main thing, but for me something that is like interesting here is like this glow gradient. And if you hover over a parameter name, it will give you a short description. And here, does it say, can be used to colorize or shapes the glow? So, okay, anyways, we click here. And then let's add like color here. So, okay, what's happening? Everything is get red. So let's add a color here. So we click once and add a color there. You can see like now the white part gets reddish and the darker part or the more blurry part gets greenish. And obviously can reverse this. So maybe like the brighter part should be greenish and redder. Blurrier part should be reddish. And with this, there's a lot of options that we can use here. So maybe, for instance, like maybe we want to make it pop, and to pop something, I think like our eyes are trained to look for warm colors in the highlights and for more like colder colors in the background. So like the Michael Bay color grading kind of thing. So we can take this thing here, say okay, like we bring the white colors a little bit towards the warm, and then we click into the cold and we bring the cold colors a little bit towards the colder colors here. And then maybe we also whenever you see these gain and bias parameter, I can really recommend to you to play with this because there's frequently is like provides a lot of flexibility. I wonder what would be. So I mean, ideally you can click here and you can just drag here left right, and you see the small little mapping curve here. So and if you are familiar with something like Photoshop or something, you might have heard about color correction curves, and this is literally the same thing. So like a straight line maps like a color to this color, like in a corner, or like half the color to half the color, or to like on the for white to white to white. But so if we put this a little bit towards the left, then we see how this is like, it's almost like a small little S. And usually, I think, let's say, graphic artists call this the sharp S because it increases the contrast. And this is the opposite. This reduces the contrast. So you can go left and right. This would be the first parameter. You can also like go up and down to move this curve along this graph. And sometimes this is just crazy, like what kind of like it's only 2 parameters, but it gives like a lot of playground. And this is not even a good parameter for this example. You'll find much more impressive examples here. We also see that this is now like a little bit too bright, and this is maybe a good moment to talk about colors and color intensity. So what I frequently do is I add one of 2 analysis operators. And if you click here, I think maybe they already come up. No, there aren't. So I know it's called ImageLevels is one. We'll take this and pin it. Then we see like this curve here. And this curve is like a little bit like no, I don't know what this curve. Yeah, maybe like a histogram, but it's not a histogram. It looks like a histogram, but what it does, it cuts the image at this line and then shows at this line the current color. So that's why, for instance, there is like this jump here, and the jump occurs because this color, like this color is darker than this color. And that's why, for instance, like here, you see that it's like roughly greenish. So like this pink color is a little bit over the green line is a little bit over the red lines. But here it's definitely the red line width, because like here this is a little bit reddish, and we see like how the colors go. So we press fit here. So we can actually move the center of this line to get an idea of like what's actually color intensity of our image. And we see that if we reach this area here, that TiXL will indicate this with this blinking line. This means that whatever you do, the output will be cut off here. So this information will be lost no matter what. So if you don't do anything about this information will be lost. And so some people like that and say like, okay, whatever, it's like it's just the way I like it. But some people would argue that that this should never occur. And for instance, if you look at, let's say, Disney movies or so, like even if you have the super bright scene, you will never see the color being cut off. They will solve this with colors, like the saturation and whatnot, but they will never exceed 90% of brightness. We have a bunch of options here, so obviously we could go into our bloom and reduce the intensity and bring it down. Maybe we can go into our bright colors here and bring it down. So be like an option. We might bring, let's say, a color grade and take the gain and bring it down. We might take something like tone mapping and bring it down. So tone mapping is probably like the smartest of the moves you can do. But yeah, there are like a tons of options that you can prevent the color clamping there. And yeah, this other operator that I'm using quite a lot, don't press here and shaking it off. This is called waveform. And I think waveform is actually like, this is a horrible name, but I think this is the name this thing is being called in the movie industry or so. And so this looks totally cryptic. So what's even going on? So like this is like maybe we can close these guys here. So click on the triangle, then the top left corner, close this, so a little bit more space. So so the waveform operator will add this cryptic thing here. And this is actually now really closer to histogram. But it's showing the histogram not for the complete image, but for every column of our image. So that's why here it's completely dark. And here it's like, it's pretty bright. It's not too bright. Okay, here there's maybe like a little bit of color clamping, but it's still like okayish. You can see actually maybe here. But we definitely see that it's like, that is reddish. And sometimes this is useful, so we can maybe bring our color grade there, bring this back in, and we can see, like, if we bring this up, we see how our image is being cropped. We even see some color bending because the this full mapping probably only puts an 8-bit texture there. Maybe we should do this before the color grading. And yeah, we can use this representation to do things like, let's say, if you have an image that has like a certain color grading and you want to get rid of this, then you could go into like, the highlights are too red. You can click this guy. Click this guy and move it into the opposite direction. They can move it and bring it back to neutral. And I see like, now the shadows are too green. You can go there and then the shadows are too green. Maybe you pull it back to away from the green. And yeah, okay, maybe. But yeah, you see it's more like now a gray donut now than it was before. I mean, obviously we could just desaturate it, but okay. I think let's just we maybe like this. I can add one more thing that is advanced. So it's probably not it's not the thing you want to see in a beginner's class, but it might be interesting for you to understand what's going on. And maybe you have like 10 minutes left. Or like actually before I do this, are there any questions of things you want to know or that you're curious about?
Yeah, actually, I do have questions.
Sure.
But when it comes to everything related to the point light and environment, is there like a specific order we have to keep in mind, or can you put like the point light after the environment and so on?
This is an excellent question. So with point lights, the last 8 wins. So we only, this is for some reason we can only have 8 point lights that are being applied to a draw mesh. This is the way the draw mesh is currently implemented. Maybe this will change in the future, but right now this is the limit for real-time lettering we are using. And but it will not matter if you do this or this first. However, with the SetEnvironment, so this will change significantly if you have this before or after the camera, especially if you render the background with a lot of opacity. Like then this will have a huge background because the reason for this is, okay, maybe we look at this guy again and then like try to keep it simple so we see a little bit more. So right now it's complaining that, hey, you don't have an environment. So let's give it an environment by creating maybe like a rounded rect. And if you are questioning what's the difference between a rounded rect and a blob, then it's an excellent question that I'm not going to answer because they're very, very similar. But so anyways, I can connect a rounded rect there. Right now, this is actually this is not the ideal setup because this should be almost like an HDRI image. And like the computation, the method we use will fail if this is a transparent image. So we have to use the left mouse button here and bring up the opacity of this image. But now we can use the position here. We can click into the gizmo field and we can move this thing around and we can actually see how this is being represented in our donut. And maybe we use the stretch parameter here to reduce the size. And then we can, this is a good opportunity to talk about something else. So if I click here on this color thumbnail, we see like we don't have the option to get it wider. You can click here and make it wider. So I can click into like this HSB at this is the B. You can actually quick tip. You can actually click here to toggle between different modes. but I wanted to show you something else. I wanted to show you, if you hold Control, you will see this little extension here, which, to be honest, this is a very awkward graphic design. I have to think about something better here, but at the moment, this is what it is. If you hold Control, then you can actually drag this and make it much brighter. It's almost like, like some kind of like photon storm there going on. And if we move this around, then we see how this is actually, this is even now brighter than our point light. And sometimes it's like, this is just awesome for like lighting stuff. We might be, okay, maybe take the stretch parameter, make this smaller, wider, and then we always have like something that's coming from the top or something like this. We can see like this ring being reflected there in our turbos. Like now somewhere there we have this ring, which is this line. So why did I say this? If we press undo, Control C, and have this configuration again, then changing the camera matters because we render this guy into the background. And if I have like this order, then our image will be inconsistent because like we don't know where to render the background into. So that's why this guy is being drawn first, so it doesn't know yet of the camera. So it uses the default camera, and then this order matters. Yeah. But there are a bunch of things where the order matters, but it's actually most important is actually for SetMaterial and these guys. I had something in mind that I wanted to show. One thing that this looks kind of interesting. It's a kind of interesting image here. I don't know, like what's even going on. I guess like I have to say sometimes I guess like this is the typical thing of like if you're working with Realtime, it's like you have like these serendipity effects where like this is actually a beautiful transition. I don't know. Anyways, sorry, I got distracted. And once again, we see like how like why is this happening? And this is happening because our rounded vector has like the default size. And that's why it's being affected by the aspect ratio of our output window. And so ideally, the SetEnvironment should get a fixed resolution. I think it doesn't need to be high or something. It just needs to be a fixed resolution. I don't know, it stays the same. Almost. Okay. Actually, now I lost my... I wanted to show like one more thing. A thing that sometimes is useful. Okay, whenever you have something like this, you might like you have the edge there that's being cut off. So just increase this a lot. If you have huge geometry, a small tip, it doesn't hurt to add a bunch of subdivisions in here. So sometimes this might affect how things are being shaded. Most of the time you will not notice, but sometimes you see like certain artifacts of triangles are too large. And I wanted to show this guy that I'm using frequently, which is called SetFog. Okay, now our image got black, white got black. So if we increase this, it got white. So like white has got white. So because we have a distance here, and with this distance, we can fade stuff from the camera distance. Maybe like without bloom, it's a little bit easier to see what's going on there. And maybe once again, we log to our camera here. So we see that further away, eventually our scene gets white. And this is actually a good example for, you see like these lines here that are coming closer and closer towards our, maybe you see like this, maybe these ramps. These ramps are these segments. So if I would have like 50 by 50 or something, and then change this, I think the transition is smoother. Yeah, obviously we can fade things to another color, let's say black or something. Okay. Any more questions? It's a very dark image, so maybe take it off our blob here. And maybe we mimic our environment a little bit. So can click here. And maybe add another blob. And what's interesting is now, so you might be wondering, oh, the blob now has a resolution of 0, 0. But it's not changing according to the aspect ratio of our output window. Why is this happening? And the reason for that is that it's using this resolution now. So if we make this square, for instance, then both of these are square. So, which is actually precisely what you want. You know, most of the time you want to apply something on top of another image if you're nesting them this way. And so I'm calling this resolution 0, 0. I'm calling the magic resolution because it just does. It's the right thing. So anyways, we can maybe stretch this guy here and maybe move it, bring it a little bit down and have, I don't know, like vision, like a small, like almost like a horizon there for our little donut scene. Yeah. And maybe, okay, a little bit over the time, but so something to make it more much more complex, to show a little bit where you could go from here. So on the, as far as I can remember, on the Blender donut, there was some sprinkles on top of the donut. So how would you do this? So we can do this by drawing things on points. So point is the central method and tool to define positions. So these positions could be obviously billboards, but it could also be lines like in an SVG, and it could also be positions where you instantiate meshes, or particles are also points. And so let's try to do this to put some sprinkles on our donut here. So, and this is going to be a little bit more advanced, but I recorded the session and I will upload it to YouTube so you can take a look there and rewind it. So, let's start by actually drawing a bunch of points here with a bunch of sprinkles, and then we try to put them on the surface. So we can start by using GridPoints, and so let's look at these points. So I click here and then I put them into our group, and I will make sure not to remove any of these lines, but to append it. And we have our points there. By default, it's using the cell mode. And cell meaning if I add more, it will use the cell, this size of like one cell to define spacing. There's also another mode, which is called bounce. And with bounce, it uses the scale and the size there. And it will now fill up this volume with points. And both of these modes are completely legit. You know, it really depends on what you want to build. So but it's important that you keep this in mind. So let's stick with the cell size mode for now, and let's only have a plane here. So we reduce the count and count and up, which is y to 1. And then maybe we have a bunch of more points here. And then we see that we can actually move this grid around because it provides a transform gizmo, and these coordinates will be stored here in this center parameter. So right now we are drawing billboards, points. So now we want to draw meshes. And so I think, so now I'm optimistic and say maybe we use a cylinder mesh here. There might even be a capsule. So let's try this. So there's a new window here that will come up with this new version 4.1, which is going to be released hopefully in a couple of weeks. And this is a small preview for that. So whenever you have an operator that loads something, an asset from your file system, then you can click on this little indicator here, this bluish one, to expose where this file is on your hard drive. And if we click this plus button toward this mesh here, here we see, okay, this is a default mesh for our OBJ, but we can actually look at these different things here to see what kind of predefined ops we have. And yeah, so these are just there. And the reason why I was looking there is, so maybe it would be nice to have like a beveled thing here, beveled cylinder, and just use this one. You can use the cylinder mesh, but I think right now the cylinder mesh doesn't have like a bevel, which it would be very useful to have, but yeah, right now it doesn't. So anyways, we take this guy here, and we want to draw this at our points. So let's go back here to our mesh, and we use the points. Let's use the draw mesh at points. It's actually even being suggested, which is great, and we can stack this in here. And I selected this to move these two at once. And snap these guys here. And sometimes, so you might be tempted to drag this there, but you can also use this input line and drag it and move this there. Also like completely legit. And we now see we have, I don't know, like donut and toast, or a toast on donut. So what's even going on? Obviously, we draw a lot of cylinders with a lot of sleep fighting there. At cut mode would not be happy, but if we bring down the size, then we see how we have a bunch of cylinders there, and so it's instancing, so it should be pretty fast. We might want to scale our points. We see that yes, there's a point scale here, but sadly there's no point scale for the arbitrary axis. So we can transform our points. So let's get rid of this guy. And let's click on the plus to insert it and use transform points and scaled. And we would like, why is it scaling there? Because we are scaling it in the object space, but we want to scale it in the point space. Let's see. And then now we can basically squeeze this down here. And we scale this down a little bit further. So these are our sprinkles. And maybe we make them pink. Can adjust the final material later. So or actually, shouldn't it be white? I think it should be more about white. Now how do we get them onto our surface there? And now it's getting a little bit more advanced. So they're just like we translate points here, we can also translate points depending on a field. And this is a field, so we can actually use this and have something called MoveToSdf. And we see that this operator is on, just like our point. It's a buffer on the GPU. And it wants some points, so we can give it these points. And then we write this in here. So, and now we see how these are being positioned. Like, I don't know if this looks yummy. That's a beginner's class for Torus decoration. But so we see, they are being positioned there on the Torus, which is actually almost like, actually pretty nice. Oh, no, what's going on? What's going on? I think my graphics card is like completely, graphics card doesn't like this at all, P. I don't know what was that, but, so let's put this guy here, and this is this guy, and let's have these points here. And I don't know why this guy is, we scale this here. Translation. So I don't know what's happened there. So let's move this up there. So, what we, so obviously we want to like decorate them a little bit nicer, so we can, adjust the count here. And, so let's click in here and maybe we reduce the count to like something that's less dense. That's interesting. My graphics card doesn't like this at all. I think this probably my cylinder is a little bit too high resolution. So maybe we use the cylinder mesh after all. Cylinder. And so it's this guy. And maybe for can reduce the, sometimes this is a good example for, so something, so you might be tempted to go super high resolution for the cylinder, but you see if I bring down the counts, like the column counts, that there is no visible impact whatsoever until eventually we start to see some difference. And so like, we just halved the number of polygons we are drawing. So which is great, of course. So let's bring down this guy and let's go back to our mapping here. So like this is here to our cylinder. And then we want to distribute them a little bit randomly. So we can maybe randomize their positions. So we can insert randomized points up on it then. Maybe scramble their position slightly. So now they are like they're stuck inside the torus. Or maybe we can also like randomize the rotation. Does this work? No. So maybe we randomize their rotation after putting it on the torus. And this is a good example where I personally like to stack stuff vertically because it's almost like a processing queue. It might almost be a little bit like the Blender modifier stack being applied from top to bottom. So after putting this onto the tools, we can again transform these points. And once again, in point space, we can move them around and we see how this is like now aligned towards the surface here of the tools. And then we can rotate them, but we want to rotate them randomly. So can we use this guy? And I will leave this in there. Randomize points. So take this guy, move it down there. And then now rotate these points randomly. And now we bring down the infinity slider to scale them here. Maybe adjust the size a little bit. Yeah, I don't know. Probably, I don't know if this is a good example, but it's some it's almost like a toe, like the Blender donut. Yeah, so a little bit advanced, but I think it's a good start. So we didn't talk at all about animation and keyframes and whatnot. But yeah, maybe we can do that in the next beginners meetup. Let's see. So maybe I have 5 minutes left. Are there any questions you have?
I think you explained it pretty clear.
Okay. Oh, okay.
Maybe I have like a question because it's like when you were trying to make those how do you call it? The ones on the donuts, the cylinders. Like, yes. How did you think about using cylinder? Like you could use maybe is it because of the shape of the cylinder that you used it? Or?
Yeah. I mean, there's for instance, we could make this, let's say, for inspiration, and this is where I highly recommend. Let's talk a little bit about workflow and how to do stuff. And of course, now we are leaving the realm of TiXL and the introduction and entering the realm of how people work. And there is no right or wrong and how to do stuff. There's just maybe some stuff works and some stuff doesn't. For you personally, not from like the operating system or something, or from software. And so I personally like to move forward, I try. So I read a book a while ago, some years ago. I can't even remember like the name, or maybe it was a lecture series or something. But it was about like brainstorming and how to get ideas and so on. And like the author of this book, they stressed the idea of distinguishing, separating divergent and converging thinking. And this, as I try to practice this a lot. And the idea is basically by divergent thinking, you move forward with a redneck speed, like break stuff, move, like you get ideas. And like the only KPI is the number of ideas is, and then the conversion thing is like you put on like a different cap and say, okay, now I'm making it beautiful, or like I tweak stuff and I think about like polygon count and like I polish things. And like this I would call, this is definitely like divergent praise, and would go into like, okay, this is the convergence is like this is I select these guys, I press Shift A to put this into like an annotation group, and I call this like ugly donut. And then I take off this guys and I duplicate it, and then I move on. Then I can say like, okay, what would be like, and then it would go into obviously we have to pick this guy here. Oh, looks the same. And I could say, okay, maybe the color should not be pink. Maybe it should be like a metal donut or something like this. And then so we have this pink material. So maybe this would be black, and it would be like full metal, like high glossy, and So I really don't know why my graphics card doesn't like this at all. I honestly I don't know what's going on. P P P really doesn't like gray marching this guy here. Not really sure why. So maybe bring down this here. Perhaps a little bit. So, and then we could say, okay, maybe this is not sprinkles, like sugar things. Maybe it's like something else. So, and then we go into, okay, we have like the cylinder material. So, what else could this be? And then you could be, okay, maybe I do this procedurally. So, because I don't know what it is, so I will use pick. And pick meaning, so we see this little shape there, which tells us, this is a multi-input, so it could be all kinds of things. And so I do maybe enum int. And this is just how I personally work. No? This is not something like, it's not even part of this tutorial anymore. So now this counts up every time this will increment 1. And we see this is already at, I don't know, 3000 because, yeah, the TiXL has been running for a while. Yes, we could reset it, but it doesn't really matter. And now we can go into load image, and maybe we reduce the count a little bit, but maybe it's also not that crazy. So I think this should be fine. So we say, okay, what happens if I bring down the marble player in here? And once again, it's getting like super slow. I'm a little bit scared that I'm running out of this space. No. I'm pretty sure why it's like so super slow. But yeah, so now every time we see it's moving there, it's something else. Maybe we can pin this guy. But still. I don't know. It's like not that much of a scene, but it really doesn't like it at all. I'm sorry about that. I think the recording with my notebook is a little bit too much here. Yeah, not really sure why this is like unfortunate. But yeah, we see how like can I bring this down? Yeah, so now we bring it down here, and actually I'm kind of curious about that. So if I bring this down, this is fast. Now this is interesting. Yeah. Okay. Now, like we just ignore what's going on. Yeah, we try to ignore it. So see, okay, we have sprinkles. We have like our little man there. So maybe we can add more shapes. So we can maybe have a sphere mesh. We can go to generate here, and maybe I think there would be. I think there should be mesh somewhere here. Mesh. Let's see what we have. So we have a torus mesh. Like yeah, what happens if we have like a torus on torus? So we can take this guy and plug it in there. Maybe we hold control to bring up the speed. And like, okay, also interesting. Or maybe and then you start iterating with like different things. And try to have like maybe like less or more spikes. Yeah, and like with the experiment with like different options. So maybe if we have like a radial point instead of like this initial point thing, and see how this works. And maybe if we now use this radial point, maybe we can increase the radius here and move like this. like this line of points around to get like different effects. And yeah, it really depends. And the crazier sometimes the idea is to play around with, the more interesting the effects are. For instance, like here, if we pause this auto update thing here, so to pause this timer there, I somehow like this thing, it almost looks like a lava thing, and then maybe it would be interesting to increase the radius here of this story to get like more interesting. And like, holy smokes, I think like this actually looks interesting. It's suddenly it's not a shape I would have thought about when I started this, but it is an interesting shape. And so yeah, I don't know, like if this answers the question, but this is how I approached it.
Okay. Because maybe I can share my screen so I can. So what I want to share is just like an image from an animation I was watching. I don't know if you can see it.
Yeah, I think it might not end up on the recording because I'm in streamer mode here. I think, wait a second, I think I can pop it out. And maybe one moment. I have to clean things up so there is no privacy stuff. So okay, let us see the streamer mode. Okay. Yes.
Yeah. So I saw that frame on an animation, the boy and the shaven. But if we don't mind the character, just the environment and and I was thinking, can I replicate something like that in TiXL? And my mind is thinking like the lake, the water, it could be like a quad mesh.
Yeah.
And those rectangles could be like a line point.
Totally. Yeah, precisely.
And I don't know if there's like something where we should train the mind to see those things. And then like the colors could be like a gradient color, for example. Yeah. And I can see those shapes sometimes, but it's difficult to put it into action then.
No. So I think this is an excellent question. And so this, once in a while, like, that this is agnostic to TiXL or Blender or whatever, it's not like, this is not a software specific question. And there are many different approaches to this. And some of them, some people get very religious about this, they think maybe it will handicap creativity, or they think it will this is the right way to do things. So I personally, I love to copy stuff, not by copying it, but by learn stuff. And I do this, I personally, I do this methodically, or not that frequently anymore, but I did it methodically. And for instance, with like this kind of thing, so it's an awesome image, and I can tell you, like the camera, like the character, this will be super tricky to replicate. Right now, this might change because we will implement GTLF animations eventually, but it's not coming in the next month or two, but it will come. But even like the quads on the floor and like the shading there is like an excellent starting point. And I would actually, maybe I can shrink this, and this was actually stupid. I take a screenshot here, and I scroll down this guy. So I'm back in TiXL, and maybe you can follow me again. So I will use Paint. I will paint this in here and I save it. My little screenshot, and I will save it to documents. Documents. There's documents, there's TiXL, and here are all our projects, and we are in the intro for beginners. And it's a good. I hope it will get. I hope the situation will improve in the upcoming version. But right now, you have to move your resources, think assets, into this folder there. You can create a image folder, and then we just save this guy as SetEnvironment. And then we can go into back to TiXL. We can use load image, and we can click here. And if we scroll to the top of the list, we should see our reference here, and we can pin it and see this is basically the picture I just shared. And what I would then do is I would literally try to reproduce the side by side by using an operator called compare images. And you can skip this thing, like rotate this thing here, or use this cool buttons that Martin implemented a while ago. And then you can go into, okay, on the left side, or like this is our reference here. So how would this gradient look like? And then you can start by having, maybe you could just look at the gradient. So here we have like linear gradient. Let's look at these colors. Maybe swap this guy and say, okay, maybe you can use Alt to grab a color there. Obviously, we grab this just the opposite way. So we have to flip this guy here, or we can, I think we should flip it like this way. And then we can think about, okay, there's like this, like, and I wouldn't even see if this is going into the green or if it's just going into the, like, where this is going. And then I would basically methodically look into, like, okay, what is the distribution, like, where, like, how, like, what kind of colors go in here to match this perfectly. And just as you said, like there could be line points, there could be like this could be a quad mesh, like just as we had before. We rotate a quad mesh by minus 90 degrees because right-handed. We draw a mesh, we set a material, we have camera, we render, we set an environment. Yeah, set environment. We look at this guy. We render this, and this is our new reference. So now we take the camera. We look at these guys here. So we increase the quad mesh here, and then this is our reference here. And now maybe we want to have like some kind of like, how is this, like yeah, and then I would go into, since this is now our gradient map, we can go into, okay, maybe it's very bright up there, so we can increase this and see, like, and maybe we have like some kind of bump, so we can have maybe fragment noise of then like a normal map. We put this into the normal map and try to figure out what would be like the right roughness to figure out where this is, like how it's being reflected. And I think it will take a while, but this is a great way to learn. Not only how like the software works, but actually to understand how these images are composed. And I think this one is totally doable. Maybe not maybe not super precise, but so that you have to look twice to figure out which one is the right one.
Yeah. Okay.
So yeah, I don't know if this is what you want to reference. Like here, it's like very interesting. You see like this thing here. So this is definitely color grade. Well, maybe definitely, but I'm pretty sure that this is a vignette. And so you would basically have something like a vignette radius that darkens the corners basically a little bit. So yeah, I know if this is what you want to do here, but there you go.
Yeah. So it's more like also training the eyes to analyze images.
Yeah. I think this is so we have on Discord we have this challenges channel, and the idea there is that you have something and think, I think it can be done with TiXL, but I just don't know how, and then you can post it there, and sometimes people are like, oh, I will give it a try. Or sometimes people do this. So I do this once in a while. So like, this is it sounds like an interesting puzzle problem. So I try to do stuff once in a while.
Okay.
Yeah, and then eventually, I think we want to have, of course, there a lot of stuff will be coming. Yeah, constantly working on the render pipeline, and there is more effects like reflections and so on the way. So
yeah, it's interesting because I was trying to do these images, and something I didn't think about in the first place was to add noise on those cubes to make it move, because on the animation it wasn't moving, but on TiXL you can make it move, so it's more. It becomes something else, but it's cool.
Yeah. Awesome. Yeah. Okay. I think. Thanks again, everybody, for joining. This was a lot of fun. I will put this recording up on YouTube. I hope it recorded. So I have, let's say, I have a legacy of messing up recordings. Wouldn't be the first time. But if things work out, it should be there. And if things
I recorded everything.
Just in case, the fallback. Excellent. And besides this, see you guys. Of course, also beginners can join the bi-weekly meetup. So the bi-weekly is not just for people, for developers and experts, but it's for everybody. And all questions and all people are welcome. And for the beginner thing, I plan to have this, as I mentioned, every first Sunday of the month. So the next one will be in 3 weeks, because now it's just the second Sunday. But from now on, I will try to do this on the first Sunday, and let's see where this is going. Yep. Thanks again, everybody. Have a great Sunday.
Thank you very much. Yes.
Thank you, sir.